Okay, in this video, we're going to talk about cis and trans isomers in alkenes. To start our discussion, I actually want to talk about alkanes and carbon-carbon single bonds. And really, this is true for any single bond, but it's possible to rotate about single bonds, right? And so, for my example, I've got one bromo, two chloroethane, and I'm showing two different conformers of that molecule. Now, because it's possible to rotate about carbon-carbon single bonds, these are actually just different conformers of the same molecule. I've got a video that kind of shows what I'm talking about. All right, so here's uh, one bromo, two chloroethane, and it's possible to rotate about that carbon-carbon single bond. In fact, at room temperature, these rotations happen all the time, so these molecules aren't static. Particularly at room temperature, we're constantly rotating about these carbon-carbon single bonds. And so it doesn't really matter, right, whether I depict the chlorine and the bromine, pointing in the same direction or pointing in opposite directions. It's still all the same molecule, just in different conformations. So again, these two are the same molecule when I have alkanes because I can rotate about the carbon-carbon single bond. The same is not true for alkenes, because it turns out it is not possible to freely rotate about a carbon-carbon double bond without breaking it. So in fact, when I draw the bromine and the chlorine as being on opposite sides or drawing it on the same side, these are different molecules. So they're different isomers from one another. And so we need some way to label them, and we do that with the trans and cis labels. So if the similar groups are on opposite sides of the carbon-carbon double bond, as they are here, then that's the trans isomer. If the two similar groups are on the same side of the carbon-carbon double bond as they are here, then that's the cis isomer. And of course, what we're not showing here is, right, there are hydrogens coming off at these other positions that we're not showing, so that carbon has 4 bonds. And sometimes when we talk about cis and trans isomers, we show the hydrogens, and sometimes we just know that they're there. Right? So in this picture, I'm actually showing the hydrogens. But the point of this slide is that not all alkenes have cis and trans isomers. If you have two identical groups on the same carbon atom, right, then it doesn't matter if I flip those, it is exactly the same molecule. And so in this case, I don't have cis and trans isomers. Right? And the same thing is true here. Right? The H and the CH3 are different, but on this carbon, both of the substituents are ethyl groups. And so neither of these molecules would have cis and trans isomers. So let's look at a couple examples of naming alkenes, including the cis and trans labels. All right, so in my first example, we're showing the hydrogens in this case, right? In this case, the fluorines are on opposite sides of the carbon-carbon double bond. The hydrogens are on opposite sides of the carbon-carbon double bond from one another. And so this is the trans isomer. So we'll name it the same way we would name other alkenes. We just put a trans in front. So I've got two carbons. So this is ethene. And I don't need to give a number for the position of the carbon-carbon double bond because there are only two carbon atoms, so there's only one option. And then I've got two fluorines, and so it's going to be 1,2-difluoroethene, but we'll put the trans in front. So it's trans 1,2-difluoroethene. Okay, here's another example. Now I'm not showing the hydrogens in this case, but we know there's a hydrogen here and there's a hydrogen here. And so in this case, right, the hydrogens are on the same side of the carbon-carbon double bond. The alkyl groups, right, are on the same side of the carbon-carbon double bond. So this is the cis isomer. So we'll name it like we would normally name an alkene, but we'll just put cis in front. So this molecule is 1, 2, 3, 4, 5, 6, 7, 8. So it's octene. And you gotta tell me where the double bond is. So it's 1, 2, 3 octene. And then we'll put the cis in front. So it's cis 3-octene. All right, here's another example. So in this case, right, the alkyl groups are on opposite sides. The bromines are on opposite sides. So this is a trans isomer. So if we're going to name it normally, it would be 1, 2, 3, 4, 5, 6, 7. So it's heptene, and it's 1, 2, 3 heptene. And so put the bromines in. So it's 1, 2, 3. So it's 3,4 dibromo 3-heptene, and I'd put the trans in front. So it's trans 3,4 dibromo 3-heptene. All right, my last example. So now in this case, we actually don't have cis and trans isomers, right? Because on this carbon atom, I have a methyl group and a methyl group. And so this doesn't have cis and trans isomers. So we'll just name it normally. And so it doesn't matter whether I include this one in the chain and this one as a substituent or vice versa. I'll get the same answer. So if we call it 1, 2, 3, 4, 5. So it's pentene. It's 2-pentene. And then I've got a methyl group on the 2 carbon. So I've got 2-methyl 2-pentene.